to find the area in between two curves, we know if I've got the top function and the bottom function, we need to integrate, and we need to integrate from here to here, so we would get those intersection points A and B. We would integrate from A to B of the top function, which is f of x, minus the bottom function g of x. And almost always we do it that way. But sometimes our functions are given in terms of x equals instead of y equals. If I were to sketch a graph of this, which you wouldn't necessarily have to do, but let's see, let's make some points here. So let's plug in some stuff for y. And if I plug in -1, that would also give me 2, and so on. So I've got points at 3, 0. I've got a point at 2, 1. Point at -1, 2. 2, -1. -1, -2. So we've got a sideways looking parabola there. And then we could get points on this either by plugging in points like that or just changing the slope-intercept form. So we've got y-intercept is -1 and the slope is +1. And my area between the two curves is this area right here is what we're looking for. The problem with doing the top function minus the bottom function like we did on the last one, that would work fine for this part here. The problem is once we get over here, the top function is 3 minus y squared, and the bottom function is also 3 minus y squared. So actually what you'd have to do is you'd solve it for y, and you'd have a plus or minus when you take the square root and treat it as two different functions. Or an easier way to do it is instead of thinking about what we're doing vertically there, it's too far. We can look at it this way and think of the rightmost function minus the leftmost function. So we're going from here to here. Notice if I go that direction, it's always this curve minus this curve here. So we can integrate 3 minus y squared. And notice it's the x value of that point. So it's the x value, so we're leaving it as x equals, minus the x value of this point. So minus y plus 1 dy. And because we're integrating this way, my intersection points, I'm going to use the y value of those points. And really we're starting low and building up this way. So we're integrating from -2 to 1. And then you guys could combine like terms and actually integrate that thing. But that's the setup of finding the area between two curves for a function defined in terms of y instead of x.